And here's what I'd like you to do. I would like you to take a moment to type this equation into your graphing calculator because I'm going to ask you for some information. So I'm going to pause the video for a moment. All right, so now that you have that plugged into your calculator, let's start with getting all of the information from the original function before we factor it into its factored form. Let's start with our horizontal asymptote. Let's see if one exists. Same degree? Yes? So our horizontal asymptote then is, what is x squared divided by x squared? 1. Okay, so there's our horizontal asymptote. Let's go ahead and graph it. And this graph has got a hole in it. Okay, so this equation is going to simplify down to a linear over a linear polynomial. So it'll be a really basic graph. So we don't have to worry about the scale. We'll just stick to the scale that's on the graph. All right, so label that y equals 1. There's our horizontal asymptote. And then switch to your purple pen. And let's get our y-intercept, which is also readily available here on the end. Our y-intercept is, you got it, negative 1/3. That's what we get when we put zeros in for all our x's. So negative 1/3, we'll go ahead and graph that too. Beautiful. So that's what we can get from the general form of the equation. Now let's factor. So I'm just going to pick up my pencil to factor. All right, so f of x is equal to, let's factor it out. Factor in your numerator into binomial pairs here. X plus 1, x plus 2, I like it. Yep, that definitely satisfies the conditions. Multiplies to 2, adds to 3. Let's also factor the denominator. Looking for the factors of negative 6 that add to negative 1. Wouldn't it be x minus 3 and x plus 2? And listen, we're in search of a hole. That's what we are focused on for this last objective. Do we have one? Right here. So let's find our restrictions real quick. We know that we are restricted. X cannot equal negative 3, positive 3, and x cannot equal negative 2. But when we go to simplify this, the negative 2 becomes a hole. So we have a hole in our graph where x equals negative 2. But we need to know where does that, because it's not an asymptote. Okay, because we're about to simplify this fraction. We do have a horizontal asymptote at x equals 3. So let's go ahead and graph x equals 3 as our vertical asymptote there. What? Oh, thank you, vertical. Thank you, that was an easy fix. Woo, thank goodness. I'm going to scroll down here real quick. Not that far. Come on, cooperate. So there's our vertical asymptote, x equals 3. But the other one, negative 2, isn't an asymptote. It's just a hole in the graph. So I'm going to go back, and I'm going to simplify my function by canceling out the common factor. So x plus 1 over x minus 3. So let's focus on that. We need to find the other part of the hole. This is the equation that we are graphing. We are graphing this equation right here. But it came from this equation, which has a restriction where x equals negative 2. Does this equation have a restriction at x equals negative 2? No. But this equation is the simplified version of this equation. So we have to figure out where's the hole. So what do? Do we plug negative 2 into the original? No, because that'll create a 0 in the denominator. Do we plug it in factored? No. Do we plug it in reduced factored? Yes. So we're going to do negative 2 plus 1 over negative 2 minus 3, which I believe is negative 1 over negative 5. So our hole is at negative 2 1/5. So let's go put a hole in our graph at negative 2 1/5. It's a little high on my paper, but you're good. Listen, there's one other thing we have yet to find. What is it? What? The x-intercept. We need to find the 0, which we can get out of the numerator right here, right? Yeah. So we have a 0 at x equals -1. So we'll go ahead and we will also graph that. But we don't have a 0 where x is -2 because we're not allowed to do -2. Remember? Okay. So that's what I got so far. And that's as much as I can get from my equation. Now I need a table of values. Well, we don't have to be crazy about the values that we pick. Let's just pick -10 to see what our graph tends to do on the left. Let's approach 3 from the left. So we'll pick -2.99, see how that does. We'll approach it from the right, our vertical asymptote, and then we'll get 10. So I'm going to need you to give me values with your calculator because I don't have it done. So somebody give me, what is the f of x for -10? 9/13? Did you say that? 9/13? Is that less than 1 or greater than 1? Less than 1. So it's down here somewhere, right? All right. Then 2.9999. I'm thinking it's pretty negative. What is it? -399? Check your math. That's not going to work. 3,999. That sounds right. Okay, so here's what I know this graph is doing. It's starting way up here, hugging the asymptote, reaching your removable discontinuity at your hole, and then graphing, cruising through those 2 points there. It's not a very good graph. And then it shoots way down to infinity, -infinity. So that's behavior there. What happens when we plug in 3.001? 4,001. So that's way up high. And how about when we plug in 10? 1.57. So 1.6. So that's like right there. And then we can't even graph that other number. It's so big. Just keep it looking fairly similar. Get the tendency of the graph because you know that's what I'm concerned about. You've got all the critical points graphed. You're telling me what's happening on the asymptotes. I'm not going to ask you today to describe all the end behaviors. I just want you to focus on what do you do when you have a hole in the graph. Okay? Questions? Okay. Then here's your chance to show me you get it. So I'm going to pause the video while you work out this problem, then come back and see if you've got it correct. Okay, so found a horizontal asymptote at y equals 0 because our numerator's degree was less than our denominator's degree. We found our y-intercept at -1/3. We factored and found a hole at x equals -2 again. So our simplified version was 1 over x minus 3. There was no 0 in the numerator left, so no x-intercept. Vertical asymptote x equals 3 and a hole at -2, -1/5. We plugged in a couple values after we drew our graph. You got your critical points in there. And you can see that this graph is very similar to the last one that we did. Maybe just shifted down one space, but there you go. So that's graphing when you have a hole. So problems for your homework are 35 through 37 and 41 through 44. Also, just for those of you who weren't here today, your review for the test that's coming up on Wednesday is on Canvas. It is part of your homework. Do your review.